Hello students, second to chemistry. We have studied last period electronic distribution. We have studied that the principal energy levels consist of energy sublevels and named SP and so on. First one consists of only S. Second one consists of S and P. Third consists of SP V, SPDF, and so on. We have studied also that any S sublevel consists of one orbital. The P sublevel consists of three orbitals. The D sublevel consists of five orbitals. If sublevel consists of seven orbitals, and each orbital can be saturated with 2 electrons, so the maximum number of electrons that can saturate the S orbital is 2. The P sublevel can be saturated with maximum 6 electrons. The B can be saturated with maximum 10 electrons. The F sublevel can be saturated maximum with 14 electrons. The S sublevel can take the number 0. What is 0 for S? This is called secondary quantum number. P sublevel takes the number 1. The D takes the number 2. F takes the number 3. These numbers are called secondary quantum numbers. 0, 1, 2, 3, SPDF. These are called secondary quantum numbers. The shape of the S orbital is spherical, as it is clear here. The shape of the P orbitals is pears-like. The shape of the D is complicated, 5 orbitals. The shape of the F orbitals, 7 orbitals, very complicated. 1 orbital only, 3 orbitals, 1, 2, 3, 5 orbitals, 7 orbitals. These are the number of orbitals in each sublevel. Maximum number of electrons, the S orbital can take 2 electrons maximum. The P sublevel has 3 orbitals, each one takes 2 electrons, so 2, 2, 2, 6 electrons maximum, and so on. The first main energy level, K, its principal quantum number is 1, which means that the first quantum number, the first energy level takes 1 because its order is the first, so its quantum number is 1. Number of sublevels on 1, which is 1s. Its shape is spherical. Its orbital is only 1 that can take 2 electrons. The order here is 1. If you square 1, you get also 1. If you multiply one orbital by 2 electrons, gives 2 electrons, which is the maximum number of electrons that can saturate the first main energy level. The second energy level, L, consists of 2 sublevels. Its order is 2. The second one, its order is 2, contains 2 sublevels, 2s and 2p. 2s is 1 orbital, p is the orbitals, so max number of orbitals here 4. 1, 2, 3, 4. 4 orbitals. if you square this 2, which is the order of the second one, squaring 2 gives 4. What is 4? Number of orbitals. So if you square the order of the principal energy level, you get the number of orbitals. If you multiply the number of orbitals by 2, you get a number which is the maximum number of electrons that can saturate this principal energy level. Let's see again the third energy level. Third, 1, 2, 3. This is the third. Its order is 3. 3 is the principal quantum number, which represented the order of the principal energy level. Contains 3 sublevels. 3 sublevels. The first SPD, 1 orbital, 3 orbitals, 5 orbitals, so 9 orbitals, max 1, 3, 5, then 9 orbitals. You can get this 9 number of orbitals, which is here 9, by squaring 3, which is the order of the third one. 3 square gives 9. 9 represents the number of orbitals. If you multiply the 9 by 2, you get 18, which is the maximum number of electrons that can saturate the third principal energy level. The fourth energy level in the same way. The fourth one, its quantum number is 4. Number of sublevels is 4. SPDF. Number of orbitals 1, 3, 5, 7. If you add the number of orbitals here, you get 16. 16, 1, 2, 3, 4, and so on. 16 orbitals. You can get this 16 by squaring 4, which is the order of the fourth quantum number. It gives 16. 16 is the number of orbitals here. If you multiply 16 by 2, you will get the maximum number of electrons that can saturate this main energy level. This is what I want to say. Thank you for listening.